Good morning, all of you. Myself, Prashant Patil. Today, we will see here unit number 1 Abstract Windowing Toolkit from the subject Advanced Java Programming. In Advanced Java Programming, we will see here unit number 1 Abstract Windowing Toolkit, unit number 2 Swings, unit number 3 Event Handling. In unit number 4, we will see here Networking Basics. In unit number 5, Interacting with Databases, and unit number C Servlets. We'll start from introduction. Advanced Java is the next level of the core Java. Core Java covers the fundamental concepts in the Java programming language. ADJ stands for Advanced Java Programming is nothing but the web and enterprise application which basically follows client and server architecture. Advanced Java covers more advanced concepts such as servlets, struts, etc. The directory meaning of the advance is forward movement or a development of improvement, and the meaning of the improve means that things that makes something better. We have to improve our basic knowledge to master in that particular field. This is called as advanced Java programming. So here we will see core Java, advanced Java, then why advanced Java we are using, and some benefits of advanced Java. Core Java to build the general application. Basically, core Java is used, we are using for to build the basic general purpose applications. Then second one, ADJ, Advanced Java Programming, to build the enterprise level applications. Java is developed into two parts. First one is the core Java, which is called as the J2SE, and Advanced Java Programming, which is called as the JEE. The core Java part covers the fundamental, which is data types, functions, then operators, loops, threads, exception handling, etc. of the Java. It is used to develop the general purpose application, whereas advanced Java covers the standard concepts such as database connectivity, then networking, then servlets, then web services, etc. Actually, in this section, we will discuss what is the advanced Java, its benefits, uses, the topics of the advanced Java. The difference between core Java and the advanced Java technologies in the database accessing. Actually, it is the part of the Java programming. It is an advanced technology or advanced version of the Java, specially designed to develop the web-based networking centric or enterprise level applications. It includes the concepts like servlets, then JSP, which is called as the Java Server Pages, then JDBC, then RMI, remote method invocation, then socket programming, etc. It is an specialization in the specific domain. Actually, most of the applications developed using the advanced Java cases, it has two-tier architecture, three-tier architecture, etc. That is client and server. All of the applications that run on the server can be considered as advanced Java application. Then here we'll see why advanced Java programming. It simplifies the complexity of a building entire application. We will see here two-tier architecture and three-tier architecture as well. Standardizes and APIs between the components and the application server container. JEE application server and the container provides the framework services. That's why we are using here advanced Java programming. Then we'll see here benefits of advanced Java programming. The four major benefits of the advanced Java that are network centric, process simplification, and futuristic imagining standard. JEE, which is called as the Java Enterprise Edition, also called as Advanced Java, provides the libraries to understand the concepts of client-server architecture for web-based applications. We can also work with web and application servers such as the Apache Tomcat, Glassfish, etc. Using these different application servers, web application servers, using these servers, we can understand the working of HTTP protocol. Also, it can be done in the core Java as well. It is also important understand the advanced Java if you are dealing with trending technologies like Hadoop, then cloud native and the data science. Also, it provides the set of services. Also, it provides the different APIs, protocols that provides the functionality which is necessary for developing the multi-thread application, web-based application, etc. Here, number of advanced Java frameworks like Spring Boot, then Hibernate, then struts are also there that enable us to develop the secure transaction based applications such as the banking applications, inventory management application, etc. The next point is that AWT. Here we will cover AWT packages, and AWT provides a platform independent. Actually, here AWT stands for Abstract Window Toolkit. AWT is the collection of classes, interfaces, and their methods. AWT package contains large number of classes which help to include the various different graphical components in the Java programming. We will see later words. AWT provides a platform independent and device independent interface to develop a graphic program that runs on all platforms including Windows OS, then Mac OS is there, then Linux is there, then Unix is there, etc. Java AWT, which is called as Abstract Window Toolkit, is an API application programming interface to develop a graphical user interface or window based applications in the Java. Java AWT components are platform independent. Why they call platform independent? Because components are displayed accordingly to the view of the operating system. AWT is a heavyweight, that is, its components are using to resources of underlying the operating system. Then the next one is that java.awt package. This AWT is the one package provides a classes for AWT APIs, such as which contains different components such as text field, then labels, then text area, then radio buttons, then check boxes, then choice boxes. Also, we will see here list, etc. The AWT tutorial will help the user to understand the Java GUI programming in the simple and easy steps. Actually, Java AWT calls the native platform operating systems, which is for creating the APIs components. Like here we are creating the different components like text field, checkboxes, buttons, etc. For example, an AWT GUI with components like text field is there, then label, and all and buttons will have the different looks and feel for the different platforms like Windows, then Mac OS, then Linux, then Unix, etc. The reason for this is to platform have different views for their native components, and the AWT directly calls to the native subroutine that creates those components. Actually, in the simple words, we can say that an AWT applications looks like a Windows application in the Windows OS, whereas it will looks like a Mac application in the Mac OS, etc. Actually, it has two packages. The first package is that java.awt package, and the second package is that java.awt.event package. Now here we can see that the first package is java.awt. AWT is the main package or parent package, and awt.event is the sub package of the AWT. The first one is that the java.awt package contains the core AWT graphics classes, which is GUI component classes. Then we can see here GUI container classes, then different layout manager classes, Also we can see here custom graphic classes. The java.awt package contains the core AWT graphics classes. Already we discussed here GUI component classes such as the buttons, then text fields, then we can see here different labels, etc. GUI container class such as the frame, panel, also we can see here layout managers such as the flow layout, border layout, grid layout. We can see here different layout techniques. The java.awt event package supports event handling. Actually it has number of classes, number of interfaces, also contains the different methods to handle the events. The first one, event classes, then event listener interface is there, then event adapter classes are there, then the event and listener, which is event handling classes, are there. Actually it all provides the interfaces and the classes for dealing with the different types of events which contains inside the AWT components. Changing the state of an object is known as an event. For example, whenever we click on the button, it generates an event. Dragging the mouse, whenever we click on the button and drag the mouse, it generates an event. This event is called as a dragging event. The AWT.event package provides many event classes and the listener interfaces for event handling. An event can be defined as changing the state of an object. Whenever we click on any component, it generates an event. That time it changes the state of an object or behavior by performing of an action. Actually actions can be a button click or cursor moving or any keyboard key pressing through the keyboard or page scrolling, etc. As you know that whenever we click on any button or any component, which is called as a button click event is there. Whenever we are clicking the mouse button and drag the mouse, then it generates the dragging event. Then cursor movement is there. Whenever we click on the keyboard, then it generates one key event. These are different events. Now in this figure, the hierarchy of the Java AWT classes are given below. Actually, the main class of this hierarchy is that object. In the Java programming or in the advanced Java programming, object is the main class and it has multiple descendant classes. The object having the descendant class is that component class, and the component having multiple descendant classes, which are button, which are shown in this figure. The first one is the button, then second one label, then next one is that checkbox, then choice, then list, and container. These are the different classes. Actually here container also having a one hierarchy. It has two descendant classes. One is that window and second child is that panel. Also window having two descendant classes. The first one is that frame and the second one is that dialog class. Panel having one class, descendant class or child class, which is an applet. The first point is that 1.1 component, container, window, frame and the panel. Here also we can see that the hierarchical structure of the component. In this structure we can see component is the parent class of the container and container is the descendant of the component class. Here also container having two descendant classes, which is window class and the panel class, and window having two child classes. The first one is that frame and second one is that canvas. This is all about the component, container, window frame and the panel hierarchy. We'll see here one by one. The first one is that component. Actually, component is the superclass of all graphical classes. Already we seen in the previous uh, figure, from which a variety of graphical classes can be derived from these components, like button, then labels, checkboxes, choice boxes, then list box, and etc. All the elements like button, text field, scroll bar, etc. are all the components. Uh, in the Java AWT, there are classes for each component is shown in the above figure or above diagram. In order to place every component in a particular position on a screen, we need to add them to the container by using some methods. These are the some methods. The first method is that void set location in bracket int x position comma int y position. Here set location is the name of the method and void is the return type. As a parameter, here we are passing x position and the y position. If suppose whenever we are passing the x position as an integer value and y position as an integer value, means what, here we are setting a component on the window the particular position from x axis from the y axis. Actually x position and the y position which is measured in the pixels. Second method is that set size. Set size is a method and the return type is that void, and it has two parameters. The first one is that width comma int height. Here width and height represents the width and height of the particular component. The next method is that void set bound. Whenever we are using the set bound method, it has four different parameters are there. The first parameter is int x position, then int y position, then third parameter is that width, and the last parameter is that height. Instead of set location and the set size, here we are using one method which is set bound. Actually set bound replaces the method for set location and set size. By using this method, we can set the position of the component on the screen. Also we can set the width and height of the component. The next one is that container. Actually container is a graphical component which is derived from component class. Already we seen in the previous figure. It is subclass of the component class. It is responsible to managing the layouts and placement of the graphical components in the container. This container having two methods. The first method is that add method. The return type of this method is that void, and here we are passing one parameter which is component object. Basically by using this method, we can add different components on the panel or on the window. Just here we have to pass the object of the component. For example, the component is that text field. Here we are creating the object of the text field space t1 is equal to new text field. Means here we are going to create the object of the text field, and t1 is an object of the text field which are going to be add as a parameter in the method add. The second one is that void remove. By using this method, we can remove the components from the panel or from the window. The next one is that window. Actually this class is base class for two window classes which are canvas and frame. Already we seen in the previous slide or in the previous diagram. The top level window without border and the without menu bar, it is created using the window class. Actually window object is a top level window with no border, no menu bar. The default layout for this window is the border layout. Basically, window must have either a frame, either a dialog, or any other window. Actually, it is defined over the owner whenever it is constructed. In a multi-screen environment, you can create a window on different screens, uh, which is constructing the window with window by using the function window. As a parameter, we are passing here window, and then here a graphics configuration. The graphics configuration object is one of the graphics configurations object of the target screen device. This is all about the window. The next one is that panel. Actually, panel class derived from the container class. It is just similar to window without any border and without any menu bar, title bar, etc. Actually, panel is the simplest container class. Panel provides a space in which an application can attach any other component, including other panels. The default layout manager for a panel is the flow layout manager. This is all about the panel. The next one is that frame. Actually, this is the top level window with border and with menu bar and resizing the corners. A frame implemented as the instance of the JFrame class. Actually, it window that has coordinates such as the border, title, uh, and it supports the button components that closes the windows, etc. Application with GUI usually include at least one frame. This is all about the frame. And the last one is that canvas. Actually, canvas is the one component which represents the blank rectangular area of the screen, uh, in which the application can draw, uh, from which the application can trap into the events from the user. An application must subclass of the canvas class in order to get the useful functionality such as creating the custom components. Thank you.